I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today I am speaking with Jace Allen, Director of ADAS and AD Engineering and Business Development at dSPACE. Thank you for joining me today.
Thank you, Sarah.
So today we're going to kind of talk about, look at some of the engineering tools that dSPACE offers. And specifically those that might help with the development of autonomous vehicles. If you could maybe start by sort of discussing some of the simulation tools that dSPACE offers to aid with the development of autonomous vehicles.
I could do that. Why don't you let me share my screen here. dSPACE really offers a comprehensive kind of end-to-end solution for data-driven development and validation when it comes to autonomous vehicles. So we have solutions starting from a data logging process and then subsequent data enrichment where I can evaluate the data that's captured at the different types of sensors that are there.
Mm-hmm.
In order to then take advantage of that, I can use that data either for training a system, for finding scenarios that you want to test with, or for just simply data replay so that I can test autonomous systems or automated systems.
Mm-hmm.
And then we have a complete end-to-end tool chain when it comes to testing a system, whether I'm testing with just pure models or offline up front, or whether I finally start testing some of the actual software, software in a loop type thing, or hardware in a loop type testing. And there we do something called scenario-based testing, where we take defined scenarios, logical or concrete scenarios, and we run them through simulation. And here it's critical that we are able to support fully sensor realistic simulations. So we can simulate real cameras, real LiDAR, real radar as part of an application, and we can simulate that for a vehicle, and independent of whatever type of vehicle it is, going through whatever scenario, whatever type of traffic situations, whatever type of road situations it might encounter. And that's really the whole thing here, is that we have this complete tool chain to take me all the way from capturing data to analyzing and doing things with that data, and then subsequently doing the simulation process to hopefully get you to some level of validation or release testing capability.
Mm-hmm. What are some of the important aspects to keep in mind when developing autonomous systems, and how can simulation tools help with those?
Well, one of the real keys about developing autonomous systems is that there are no requirements or rules. There's no perfect set of requirements for a system because you could encounter, who knows what in reality as I drive a vehicle through some sort, through any type of a scenario.
Right.
It's difficult to say, here are all of the requirements for a system like this. So it's really important to do simulation. You can't possibly drive a real vehicle through enough types of situations. I also, can't really do this in, kind of the classic testing sense. It's difficult to say, here are all the different types of scenarios I need to encounter. So we can use simulation to really expand upon that, to run, thousands of simulations in the cloud, or even, millions of miles of simulations. And this is what companies like Google are doing, and, some of our customers that are working with our tool chain are doing this. There's a standard coming in the automotive industry called SOTIF, or safety of the intended functionality. And the SOTIF standard says, I need to run through these types of scenarios. I need to use simulation to do this. I need to try to find some coverage that, mitigates the liability, or mitigates the potential danger that you might run into. And that's really have this need for simulation,
Mm-hmm.
to do that type of testing.
Okay. And so is it safe to assume then that using the simulation tools would help speed up the design process of autonomous vehicles, or what kind of benefits can they provide?
Yeah, it would definitely speeds up, because now I can take this same simulation environment, I can run thousands of simulations in the cloud. So I can run a lot of simulations in parallel to do the testing I need to do. That helps me. The safety comes into play when I can now test simulations of sensors in the loop. So I can run real-time sensor simulation for radar, lidar, and camera all simultaneously. So for a real application that might have multiple cameras and multiple lidars and multiple radars on a vehicle, I can run that simulation not just on a workstation, but also in multiple instances in the cloud. And that really gives me a greater scope or greater coverage of testing capability that I have.
Hmm. Okay. And so I know dSPACE recently acquired the company Understand AI. How will that acquisition help with the various tools that you guys can offer and um, for development of autonomous vehicles?
In the last year, dSPACE acquired Understand AI. And what's key about this is that really all of the technology, 99% of the technology that's being developed for an autonomous vehicle or autonomous system uses deep learning or uses AI to analyze the sensor data, to analyze the camera, the video, the LiDAR, and the radar data to determine, what to do for the situation that you're encountering, the scenario that you're driving through.
Mhm.
And so providing a tool or providing tools that take advantage of the AI technology is important. Understanding how our customers use the AI technology to do that perception and that data fusion is very important. So bringing a high-end skill set with Understand AI into dSPACE was very important for us. What's interesting about UAI is that they're really one of the preeminent leaders in the industry for their tool chain in terms of what they can do with data selection, annotation, and the quality and the speed of annotation that they can do based on their automation capability. And that was a big thing for us. We're all about automation. We're all about test automation, automating our tools to help people do things more effectively and faster and with higher quality.
Mhm.
And UAI was built in that mode. That's exactly what they do. And one of the really interesting aspects of AI in our case is that, we talked before about having to test for these different types of scenarios that you might encounter. And it's difficult to come up with those scenarios. Where do I get those scenarios from? Do I just try to dream up these scenarios, different situations I might encounter? Well, all these companies are out today driving around capturing data from different, scenarios, different environments they drive through. And so with the combination of UAI's technology and our technology for simulation, we're actually able to take captured data and generate these scenarios from the captured data. And so you can use AI to look through captured data and find good scenarios to test with. And then using our technology now, you can create virtual scenarios or logical scenarios from these captured data. And then I can use our powerful simulation tools to use testing methods to use those scenarios, really improve the reliability of my system based on the testing I can now go through. So that's a very powerful thing we've just released. We expect the industry will be very interested in using this technology, being able to generate those scenarios from captured data like that. So
Mhm.
that's what UAI brings to dSPACE.
Okay. All right. And so, can the simulation tools that dSPACE offers for uh, developing autonomous vehicles and even other types of vehicle systems, um, what types of applications or vehicles can they be utilized for? Can it be used for heavy duty off and on highway vehicles? Is it more geared towards automotive applications, or do you guys kind of run the gamut?
We have quite a few customers in the commercial vehicle off-highway area. Some of our biggest customers are there, like Caterpillar, CNH, companies
Mhm.
like this, MAN, other trunking companies, Daimler Trucks, people like that. Um, we also have some startup companies, like Too Simple out of California is also a company utilizing our technology. It's a lot of this, a lot of the things you see in the industry, a lot of the things that are advertised today are, relative to automotive, relative to people talk about, right? And you don't see a lot where people talk about, commercial vehicles or what's there. We really believe commercial vehicle is going to be one of the first industries, it already kind of is, that are implementing autonomous technology because there's instant payback to be able to drive trucks 24/7, to be able to do point-to-point delivery type, applications. So it's really easy to see a translation of the same technology between passenger cars and commercial vehicles for, you know,
Mhm.
trucking systems like that. And so the same technology we're doing for applications like platooning or highway pilot are
Right.
clearly, you know, applications we can test for. The other thing that's really important to realize here is, you know, when we're doing this type of testing, it's not just these sensors on the vehicle, it's also the telematics interfaces that are important here. It's getting information from other vehicles around you or from the infrastructure or from, you know, GPS, from things like that are, kind of drive these systems. And um, not just trucks, but all, you know, commercial vehicles, off-highway vehicles have a good amount of telematics systems built into them. You
Right.
know, that's become a big player in the industry already. That's critical to be able to do these types of applications anyway. Um, I also think it's important to kind of look at, you know, we've had some applications with some of our customers where they're looking at not a driving application, but looking at utilizing the same types of sensors to do things like mining
Mm.
automation or mining applications or
Right.
digging holes in a
Right.
field and using a camera to look at that to control
Yeah.
that. And so those types of applications have the same type of needs for testing. You know, I still need to test that system and make sure it's not that it's going to do its intended job. And so the interfaces we use to connect cameras or LiDAR for, you know, driving on a highway are the same interfaces I'm going to use for testing like this. It just comes down to, can I simulate that environment for them to be able to do that type of testing? And so you know, the everything we gain in terms of our technology and capabilities based on the sensor interfaces and the telematics interfaces in automotive, you know, easily apply to commercial vehicle and off-highway applications.
Well, thank you very much for taking the time to speak with me today and go over some of dSPACE's simulation technologies and how they can benefit with the development of autonomous vehicles. I really appreciate it.